Hi, my name is Peggy He, and I was an undergraduate student studying decision science at Carnegie Mellon University when working on this research project with Professor Clotilda Gonzalez from Dynamic Decision Making Laboratory at Carnegie Mellon University. So my research project aims to investigate adults' linear thinking. Previous literature has shown that adults respond linearly to nonlinear complex problems such as carbon dioxide accumulation, investment decisions, and others. A hypothesis has suggested that perhaps the adults' educational systems, particularly in mathematics, prevents them from solving nonlinear problems correctly. Indeed, children have been found to apply linear reasoning in solving nonlinear problems, like word problems involving areas or volumes. The question is, would adults exhibit similar linear thinking while solving nonlinear math problems as kids do? To answer this question, we use math problems using early education and present adults with those problems. We are curious whether adults will use linear thinking in these problems and whether their math abilities would help them in solving those simple problems for children more accurately. We conducted a research survey on Amazon Mechanical Turk and paid people based on the accuracy of their answers. So each of the 99 adult participants completed a survey consisting of 3 parts: demographic questions, 10 linear and 10 nonlinear questions, plus an attention check question, and a math questionnaire from Chi and Gonzalez paper 2015. Our participants are all adults with a mean age of 38 years old, ranging from 21 to 69 years old. Around 46% of them gained a bachelor degree, and around 31% of them graduated from some college. 12% of them graduated from senior high school, and around 9% of them earned a master level degree, and only one participant gained his or her highest degree at primary school. So around 65.66% of people come from a non-STEM background, and around 27.27% of those people come from a STEM background. And the question is not applicable to around 7% of participants. In the linear questions, the input x relates linearly to the output y. In the nonlinear question, the function of x and y should be written in nonlinear forms like a quadratic form. The purpose of the math questionnaire is to measure participants' math abilities. Let's look at the 2 examples on the poster. The first bicycle question can be solved using 6 multiplied 3 equals to 18, because we know that Cindy's speed is 3 times the speed of Jerry's. So if Jerry has ridden 6 miles, Cindy has 3 times of Jerry's distance. Thus, by multiplying Jerry's distance by 3, we can get the answer, and since the solution can be written in a linear from ax, where a is a constant and x is the times of difference. We call this type of question the linear problem. In the second farmer example, in order to cover a square pasture of 2,400 inches, we'll need 6 times 3 times 3. That is 54 bags of seeds, since the square has 2 sides. Because the solution can be written in ax squared, which is a quadratic and thus nonlinear form, we call this type of question the nonlinear problems. So we calculated the overall accuracy to the linear and nonlinear questions and the fit of their answer in the nonlinear questions to a linear response to determine whether they answered linearly to a nonlinear question, which we called correlation heuristic, as in the studies of Gonzalez and Sterman 2009. Similar to what past studies show of children's behaviors, adults are significantly more accurate in response to linear than nonlinear questions. We found that there is a positive correlation between linear accuracy and the use of correlation heuristic, which indicates that people who are better at doing linear problems tend to apply more linear solutions when they are solving nonlinear questions wrongly. However, we found no significant relationship between the adult's math ability and the accuracy in the task, and no negative relationship between the math ability and the use of correlation heuristic. It is discouraging that adults, most of them with high-level education, cannot answer simple nonlinear math problems. In fact, the levels of accuracy in nonlinear questions are comparable to those of children who are 3rd to 8th graders. Furthermore, it is clear that many adults tend to use the correlation heuristics in answering nonlinear math problems, which results in an incorrect answer. To our knowledge, this is the most convincing test of adults' linear thinking. Adults exhibit similar linear thinking than children do. Thus, the problem of linear thinking is not directly related to the complexity of everyday nonlinear problems like carbon dioxide accumulation or investment decisions, but it is rather more deeply rooted in very early education. Thanks for listening.